Hi, I'm Boss One Officer of Primary 6 from Indian Primary School. This time, still at ordinary differential equations. Ordinary differential equations, we do have many different types of examples. All these examples, we need to know what types of method we can use and different types of combinations of different methods. Okay, so that means we'll just look at these examples and of course explain some of these methods along the way. So let's look at this example which we have right now for this lesson. Y prime, and this is equal to 3 over 2, then y, plus 1 over 3, x, then minus 3, then over 3 over 2y, plus 1 over 3x, plus 1. This is our example for this lesson right now. Let's first take a look. What kind of ordinary differential equation is this? First order, non-linear, non-homogeneous. Okay, so it's this kind of ordinary differential equations. What can we have? Of course, these methods are first thing of variable substitution. And yes, I'm going to use that, the variable substitution. But what did you realize about this? These two, when we look at them separately, the numerator and the denominator, we look at them separately. We look at them as, well, you say it's equations. You realize these two are both straight lines, and they're in fact parallel to each other. That means in this type, it's actually a very, very special example, whereas they are both straight lines and in fact parallel. So for this type, variable substitution, let. So for this, we're going to let u be 3 over 2y plus 1 over 3x. So then you still need to find what is y. And for this part, y is, okay, so this part, you need to divide it to the other side. Okay, then this part also minus. So it's like this. Then after that, you can both sides differentiate. So you have something like this. So this is what you get. That means afterwards you have to put everything inside here. Okay, you need to put everything inside there. What would you have? Y prime? Well, of course you need to change it into that form. Okay, this part is still u, here minus 3, then here is plus 1. Okay, you get something like this. You can move this to the other side. Now what happens in this part? Here you have 11u, here minus 27 plus 2. So it's minus 25. Okay, something like this. Then on both sides you get times 9. Actually for this part, u prime, you can start changing it into du dx. Okay. Then after that, you can divide this to the other side. Then here you leave du. So 6 and this over dx, you move it to the other side. Then right now here you can both sides integrate. By this point, you can't straight away start to integrate. Well, for me, I would want to try here times 11 here. This denominator has this 11u. So try to times 11 here. That means this part you need to divide by 11. This part you can straight away integration away first. Then this part. This part. What do you have here? Now here you see this 11. So you have another 11. Okay, that means 1 over 1 to 1. Why not we just times one of these 11 on both sides? So that means here you only need 11. So then you don't need to write all those 1 to 1. And up here is 36. And over here you get ln. Ln is also the natural logarithm. So then here you need to times 11. And for this arbitrary constant, well, it will still be an arbitrary constant. Now you have to change this. Then after that, we're just trying to arrange this. For example, just that C, you put it on just one side. So there's one more line, I'll just write that here. Okay, you get things like this. But are you really sure that this is the right answer? You're not really sure because it's only the first few times we're having this type of example. So we can make a verification. Or we can just say, we can verify this. So for this verifier, I'll just be using this part. Then from this part, this will be equal to 0, since constant differentiation is a 0. Okay, what do you have here right now? You have all these things. Well, let's think of some way to try to simplify things a little bit, perhaps. Like, for example, y prime, we can put it on one side here, for example. Y prime, we can put it on one side. Then here you have another y prime. Then after that, the other, like, without the first differentiation of y, you put it on the other side. Then after that, at this part, well, yeah, try to continue simplifying things. You can first have this y prime taken out since all of these terms in this front part or the left hand side, you all have y prime. Here will be 99 over 4y, then plus 11 over 2x. Then, wait a second, this part, is it minus or is it plus? Here you get 75 over 2. Here, you get 54. Obviously it's a plus. But plus how much? With a quick calculation, you get 33 over 2. The next part over there, you just straight away find. Okay, negative 75, here is minus 12. Okay, so this is what you get. Then after that, y prime, you'll have, okay, let me just write this whole thing down first. After that, for this part, what do we need? So with a comparison, here you need to have 1. That means, of course, you divided by it. This is 33 over 2. So let's check the results. Divided by 33 over 2, that means times 2 over 33. So you get 3 over 2y. That means this y below is also 3 over 2y. Then this part's 1 over 3x. So here is also 1 over 3x. Then here will be a negative 3, and of course here's plus 1. Okay, making a quick comparison between what we got from the verification and what is this called? Okay, this is the ordinary differential equation that we have at first. So they're all the same. Okay, so that means this solution that we've got are all right. So I hope that you can understand this lesson so far. And if you like our videos, don't forget to subscribe to our channel. Thank you for your watching.